So at the last few slides, you keep hearing, I keep saying, I keep talking about, I emphasize on conversion of energy, like elastic potential energy, you need to convert it to some other forms of energy. Because of the second objective, you have this principle and you have to apply this principle to a lot of your questions and a lot of your calculations. So what it says is that, okay, so what we have here is the principle of conservation of energy. What it means is that the amount of energy we have is constant. Then the energy cannot be created. It also cannot be destroyed. That means if it's 100 joules of energy, it will always be 100 joules. So what happens to them is, what happens to the energy is that it becomes transformed. It gets transformed into one form to another form. So easier said than done. So we got the same guy again, and then we get the staircase. Okay, we have the staircase guy again. Then A guy is here. Why not I put him on the ground first? Okay, let's put him on the ground first. He's here. Then he is going to climb, and then he will reach here eventually. So this is the final position he will be at, and the initial. So he has eaten lunch, and then he's going to climb the steps. What happens is he probably ate a pack of chicken rice. So rice is stored energy. So he has chemical potential energy within himself. Then he climbs up. He moves. When he moves, what kind of energy does he have?
Kinetic.
Yeah. So this thing becomes kinetic energy. So chemical potential energy gets transferred, become Ke, transformed. So let's give the chicken rice amount of some calories. So let's say it's 1,500 joules. So he moves, and then the chemical potential energy gets transformed into kinetic energy. So now there's 1,500 joules of kinetic energy. And he goes up. So what happens when he goes up? What happens to gravitational potential energy? Will increase, right?
Yeah.
So let's say
from the Ke convert to gravitational
yeah.
potential.
So let's say he's at the midway point down here. So that means, right, half of his Ke will be converted into potential energy. So now Ke is only 750 and Pe is 750. Right. Then he continues to climb. When he reaches the top, then, you know, gravitational potential is the highest at the top. So Pe will be 1,500. And because it's at the top, he's no longer moving. So Ke is 0. So then if you notice, at every point initially, chemical potential energy is 1,500. Then over here, it becomes Ke 750, Pe 750, which totals up to 1,500 again. And finally, Ke is 0, potential energy is 1500. Then it shows that this tree, it can not be destroyed or energy cannot be created or destroyed. Then energy gets transformed from one form to another, and then total energy is constant. Okay, I have one big question. Where did this 1500 chemical potential energy in the chicken rice come from? Where did that energy in the chicken rice come from?
It converted into Ke. It
No, as in
converted into Ke.
it's not covered. I'm asking you, where did the chemical potential energy in the chicken rice come from?
Come from the chicken.
Then where did the energy from the chicken come from? Making your life
Come
miserable.
from,
Come from where?
come from the egg.
Chicken come from the egg. Then where did the energy from the egg come from? You're gonna kill me, right? You know, there's this thing called food chain. You know this thing called food chain, like probably studied long time ago. Then they say you have producer. So the producer, which is the plant, will take energy from the sun and then make food. So producers are the plants. Take solar energy, make food. Then after that, make food already, right? The plant eaters will eat the producer. Then the plant eater gets the energy from the producer. So that means the energy from the sun is being transferred to the plant eater. Then the plant eater will be eaten by an animal eater, and then the energy will get transferred to the animal eater. So in this case, chickens eat sweet corn, right? Maybe say sweet corn. Oh my gosh. They eat corn. So the producer is corn from the sun, take energy from the sun. Then it goes to the chicken. So maybe say 1500 joules of energy from the sun goes to the corn, and the chicken takes the corn, and then this get consumed 1500. Then human eats the chicken, so you also get the 1500. So all energy on earth actually come from the sun. So if you want to talk about principle of conservation of energy, right, it is still valid because energy from the sun gets converted to energy in the plant, gets converted into the energy in the food, that in the animal. Then humans eat it, energy becomes energy part of you. Then after that, you have your Ke, then you have your Ki. Okay? Next. Example again. Do you know what's a pendulum?
That swing from left to right.
That you have a metal thing, then got some rope, some hook, then they hang to a rope, and then you suspend it somewhere. Then as what you say, it can swing left to right, right to left, etc., etc. So it swings. So then in this picture, it shows the movement and position of the pendulum. So it swings it starts from here, and then it goes this way, and then later on, maybe it will come back this way. So it's divided into 1, 2, 3, 4, 5 stages. So can I say point A and point E are at the highest point?
Yes.
So highest point, that means it will be maximum
GPE.
GPE. So maximum GPE on both ends. Then the KE is 0 because it's not moving. Then it goes down. Once it goes down, it starts moving. That means it's moving. What color can I use? So once it goes down, it starts to move. When it starts to move, it will have some KE. So the KE will increase. Then PE will reduce. Then it will go to your point C here, which is the lowest point. When it's at the lowest point, you know that there is 0 GPE. Then it will have maximum KE. Then it goes up again. So when it goes up, the speed will drop. So the KE reduce. Then energy becomes PE. KE will become PE again. Then you'll go back to the maximum height and then 0 KE again. So this thing, right, it goes in a cycle. So it goes on and on and on and on. If it's in a vacuum, if it's, say, if the setup is in a vacuum, then this movement will go on forever. If it's in a vacuum, this will go on forever. Why? Why? Why will it go on forever if it's in a vacuum?
Because in a vacuum, there's nothing.
So there is no air. When there's no air, there is no air resistance.
There's no wind. There's no air resistance. So there's nothing to stop the pendulum from moving.
So the energy will be transferred from KE to PE, PE to KE. Energy is not lost because of the air resistance. So that's why this thing will be going on and on forever if it's in a vacuum. What will happen if it is not in a vacuum?
Then it will go on and eventually stop.
Eventually stop, because then it will be like this. It will first swing from here to here. Then the next moment, it will swing smaller. Then eventually, it will become even smaller, the magnitude of the swing. Then after that, then stop. Something like that. So, next example. Okay, say this. Now it becomes like this. we go into one section of the diagram, the swing. See, I only left with this much here, this much. Not the whole swing already. So then we zoom in to the bottom and then the top. And then they tell you that the total mechanical energy is 200. When it's at the lowest, the kinetic energy will be 200 joules. Then PE will be 0. The total mechanical energy is KE plus PE, so it's still 200. When it's at the maximum height, then it will be PE maximum, which is 200. Kinetic energy is 0 because it's not moving. Then the total mechanical energy is still 200. The interesting one is in the middle here. In the middle, that means half of the K, there will be half KE and half PE. So that's why you have 100 KE and 100 PE. So it has both energy. Okay? Okay.
No.
This is another example. Now it's a slope. Then you notice it's 3 points. One is like the minimum height, the bottom of the slope. One is the maximum. Then one in the middle again. So at the minimum height, that means the lowest point, right? The height is 0. The vertical height is 0. So there is no PE, only KE. Then the maximum height, because it's stationary there, you only have PE, which is 200, no KE again. So in the middle, then will be 100 for KE, 100 for PE, half. Then the total is still the same 200. Nothing is lost anywhere. So no energy is being destroyed. Okay? Can? Can? You say can, then I'm ready. You want to sort out whatever we have until here? Next one is example, some more example. If you need a break, we can take 5 minutes. Okay, next. So the next section down here is more woody. What happens is you get a scenario. So let's say a diver on a springboard. So then they ask for energy conversion. So you would have to write what energy converts to what energy in the scenario. So then you need to know the different kinds of energy, different forms of energy, and whether they can fit into your story or not. So a diver on a springboard. So what happens is the diver will force the springboard to bend. So energy first comes from the diver. So it becomes stored chemical potential energy from the diver will cause the diving board to bend. So when it bends, stretch, or it gets compressed, it will store elastic potential energy. So it becomes elastic potential energy. Then after that, the diving board will come back to its original position. So initially like that. Then after that, the diving board will go this way. It gets stretched. So it goes down. Then energy from the diving board will be released, and then you go this way. Then the diver would go up and then fall down. So here you have chemical potential energy, then become elastic potential energy. Because the very instant he moves, so it becomes kinetic energy. So energy gets converted in this manner. Then if it's a cyclist will go up with the bicycle, go up the hill, to the top of the hill. So initially it is at the bottom, the cycle, so energy comes from the cyclist, which is from food again, so it's chemical potential energy. Then he moves upwards, you get Ke. So chemical potential energy gets converted to Ke. Then he reached the top of the hill, so he's here. Then it's gravitational potential energy. Then the next one, you burn fuel. Burn fuel, what should I do? So wood, log. Then I draw some flame. Oh, terrible drawing. Okay, flame, like that. So the wood that is being burned contains stored chemical energy. Once you burn it, it becomes fire. Fire will give off light. Fire will give off heat. That's why the conversion is like this. Then you can have many other types. So you have connecting a battery to the lamp, you will get stored energy. Battery will always have this. So then it becomes electrical energy, then it becomes heat and light from the filament light. So you can just read the rest. In any question, right, they will give you a scenario. So you will have to figure out the scenario, then maybe do some calculation because to answer the scenario that they give you.